Hi, my name is Charlie. Today we are going to be doing mathematics and we'll be treating psychogeometry today. We are just still in the process of dealing with the topic geometry in mathematics. So if you want to check our previous videos on geometry, you can go to this page, go and check for those topics. Introduction to geometry and others about geometry. So this particular topic is on psychogeometry. So we will start in this very class. We are going to treat the theorems of geometry, because I so much believe that if you want to do something, you do it well. And if you don't teach students the theorems, I will just come here. I can come here and solve problems on the board, which it will not be everybody that will be able to follow. So by the time I treat this theory, when I'm not applying them, I believe it will be a good avenue for students to follow. So we are going to be treating, I have some theories on the paper I am holding on my hand now. So we are going to be treating them. The very first theorem we have here states that the line joining the center to the midpoint of a chord is perpendicular to the chord. The line joining the midpoint of a chord to the midpoint of a cycle to a chord is perpendicular to the chord. What does that mean? It means that when you have a cycle like this is a chord. Let's say this is the center of the cycle. If I know the midpoint of this chord, maybe this place is the center, the midpoint, which is the center, and I draw a line from the center of the cycle to the midpoint of the chord. So what it means that this place is perpendicular. Immediately, what it means that whenever you draw a line from the center of the cycle to the center of the chord, and it meets at the center of the chord, you will have a perpendicular angle. This place will be perpendicular, this place will be perpendicular. What is the meaning of that word perpendicular? So many of us do not understand what it means. It means that it will be angle 90. This place will be angle 90 degree. This place also will be angle 90 degree. Why is it angle 90? Because I draw a line from the center of this cycle to meet a chord at the center of the chord. So just know that in real life, when you are able to construct, when you draw a cycle and you measure the length of the chord, you draw a line from the midpoint of the cycle to that center of the chord. Just know it's a theorem. So I believe by now you should know the meaning of theory. This is the first theorem we have on this book. On this book paper I'm holding, which says that when you draw a line from the center of a cycle to the midpoint of a chord, it will give you a perpendicular angle, which we have illustrated here. Okay, let me repeat. The line joining the center to the midpoint of a chord is perpendicular to the chord. I said perpendicular means angle 90. In physics, they either use perpendicular or they say normal. When they say normal in physics, usually they mean angle 90, like at angle 90 to a particular point. So they can they also use perpendicular, but in mathematics most of the time we use perpendicular, which means at angle 90, which means if I just draw a cycle like this and I am able to locate the center, then I draw a line, I draw a chord to it. I draw a line from the points of the cycle to that point. I just know that even without measuring this angle, I just know that it is angle 90. Let's move to the next one. The second theorem states that equal chords of a cycle are equal distance from the center. Equal chords of a cycle are equal distance from the center. Let's say this is a cycle and this is the center of the cycle. And I draw a chord here. Let's say this chord is 2 centimeter. And I draw another chord from here. It's 2 centimeter. And I draw another chord from here. 2 centimeter. And I draw another chord from here. 2 centimeter. Since it is 2 centimeter, 2 centimeter, 2 centimeter, 2 centimeter, just know that the distance from here to here is the same thing as distance from here to here, is the same thing as distance from here to here, and the same thing as distance from here to here. That is what this particular theorem says. Let me repeat. It says equal chords of a cycle are equal distance from the center of that cycle. That is what this particular one. So it's very paramount. These are the tools you hold in your hands for you to be able to solve problem on geometry. The next one, let's quickly talk about the next one. It says the angle which an arc of a cycle subtends at the center is twice that which is subtend at any point on the remaining part of the circumference. That is, angle subtend at the center is twice that of the angle subtend at any part of the circumference. What does that mean? If you have a cycle like this, let's say you have a cycle, this is the midpoint, then let's say you draw a line from here to there and you draw to the circumference, then this is the angle subtend at the arc. This is the arc. Okay, this is the arc. Then if you draw a line from here to any part of the circumference, you draw another line to meet it. So what they are saying is that whatever you have here is 2 of this. That is, if you have, for instance, 2 here now, just know that this place will be 4. That's what they mean. Which means in a question, if I give you a question on cycle geometry, for instance, and I give you 2 here, and I ask you to calculate here. Maybe I put A here, or no, A here. I say calculate A. What do? You just say 2 times 2, because 2 times 2 here will be 4. Angle subtend at the center is 2 of any one at the circumference of the cycle. Angle subtend at the center is twice that of the angle subtend at the circumference of the cycle. Another way you can see have something like this is maybe you have something like this. So let's say this is the center of the cycle. You have a line like here, a arc like this. You have an arc like this. Draw it to circumference. This is the circumference of the cycle. You draw it to from this one to the circumference of the cycle. So this angle, not this angle, because this one is also at the center. This angle, that is this outer angle, this angle, just as this angle. Look at the angle that is at the circumference of the cycle. Look at the angle that is 2 times of it. So this angle is 2 times what you have here. Just the same thing. If you have 2 here, you have 4 here. If you have, let me say 2 here, you have 1 here. So that is it. Angle subtend at the center is twice that of the angle subtend at any part of the other part of the circumference of the cycle. So that is the third theorem we have discussed today. We are going straight to the next theorem. We are going straight to say angles in the same segment of a cycle are equal. Angles in the same, we are talking about cycle geometry, don't forget. Angle in the same segment of a cycle are equal. Look at, let me say you have a cycle like this. You have a cycle like this. This is the center of the cycle. Okay, if I draw a line here like this, for instance, if I draw a line here like this, then this is one segment, this is another segment. So angle on the same segment of a cycle are equal. If I put my pen here, I draw a line like this, and I put my pen here where this one meets, I draw a line like this. It's the same thing with when I put my pen here, I draw a line like this, and I put my pen here also, I draw a line like this. Like this. It means that this angle is the same thing as this angle. So wherever I draw, if I put my pen here again and I draw a line like this, and I put my pen here, I draw a line like this. In as much I draw the line from here and to here, in as much I draw the line from here to here, all these angles are what? Equal. That angle on the same segment. They are on this segment. Okay? So this angle are on this what? Segment. Angle on the same segment what? Are equal. Angle on the same segment of a cycle are equal. So when you draw a angle, maybe for instance, I tell you, I draw a angle like this. Let me say I have something like this. I have something like this. I have this is the center of the cycle. I draw a line from here, and I draw a angle on this segment like this, and I put here this angle, I say 2 degrees. Then I put and I draw another angle from here, and I draw it like this, and I put here S. I ask you to calculate S. This just say S is equal to what? 2 degrees. What's the reason? Angle on the same segment. Just open bracket, you write angle on same segment. So that is how you use all this information to solve problem After we are done with this, we'll just talk about how we can use this information to solve problems. We'll solve many examples on this. Okay, make sure you put these theorems in your head. They are very paramount. They are the tools you hold with you to solve problems on geometry. Now, the next one is this, which states that angle in opposite segment are supplementary. Angle in opposite segment are supplementary. Angle in opposite segment are supplementary. Or you can, it's the same thing as when you say the opposite angle of a cyclic quadrilateral are supplementary. You are saying the same thing. The opposite angle of a cyclic quadrilateral are supplementary. So some people mistake something like this with cyclic quadrilateral. They mistake something like this. You know, this one, when I said angles obtained at the center is twice that. When I said this, and look at this other one, this new one. This was the former one, example of the former one. Look at this one. Maybe I have something like this. Some people mistake these two. They are not the same. They are not this. This is a cyclic quadrilateral. This is not a cyclic quadrilateral. Okay, this one is a cyclic quadrilateral. This is not a cyclic quadrilateral. Okay, now if you check, all the vectors touches the circumference of the cycle. Look at where these two lines meet at the circumference of the cycle. It touch the circumference, it touch the corner, right? This one touched the circumference, this one touched it, this one. If you check here, it's only these three that touch it. This one did not touch it. So this one is a cyclic quadrilateral, while this one is not a cyclic quadrilateral. So what this rule is saying, that the opposite angle of a cyclic quadrilateral are supplementary. It means that whenever you have a cyclic quadrilateral like this one is the former one. Let me clean it. This is not what we are talking about now. I just want to differentiate. I want you to understand the difference between these two. Cyclic quadrilateral, you have to identify what a cyclic quadrilateral is. How do you identify? You check all the corner whether it touches the circumference of the cycle. That is how you identify the cyclic quadrilateral. Now, if you have, what the rule is saying, that when you have a cyclic quadrilateral, you also know that this one plus this one must be equal to what? 180. This one plus this one must be equal to 180. That is what it means. That is what it means when it says that the opposite angle of a cyclic quadrilateral is supplementary. Supplementary means they add up to 180. That's what it means. When they say something is supplementary, it means that when you add the two of them together, it will give you 180. That is what it means. That is the grammar there. When you add this opposite angle of a cyclic quadrilateral together, it will give you 180. Let's say you have S here, you have Y here, you have A here, you have B here. It's saying that S plus Y is equal to 180 degree, then A plus B is equal to what? 180 degree. That is what it means when it says opposite angle of a cyclic quadrilateral are supplementary rather. Okay, opposite angle of a cyclic quadrilateral is supplementary. Now the next one we want to talk about now is angles on the same angle. The angle in a semicircle is equal to 90 degree. Angle on a semicircle is 90 degree. Look at a angle. Look at a cycle now. Now, if let's say this is the center, we usually use O. They represent center. We say center O. We use O to represent center. Let's say this is the center, and you draw a line from here. This side will be a semicircle. If I clean here now, if I clean this place out, you will now have half of the cycle. We call it semicircle. So this place down, this place down, this place down is a semicircle. This place up is a semicircle. So the angle on a semicircle, what is the angle on a semicircle? This is, if I draw a line from here now, I draw a line from here, and I draw a line from here. This straight line, so you know I am not using ruler here. If I draw a line from here, this particular theorem is saying that this is the angle on this semicircle. Now this is a semicircle. This angle now is the angle on a semicircle. They are saying the angle on a semicircle is 90 degree. So you see, since this place is 90 degree, I can say it's a perpendicular, is a right angle, is a right angle. Yeah, it's a right angle. So if how do I write it? Do I write it like, do I draw it like this? No, I don't. You don't write right angle like this. You draw a straight line. Look at it. I draw a line like this. I draw a line like this. It means that it is what? Angle 90. If I draw it like this, it means it's angle 90. But if I draw it curved, it's not angle 90. You have to take note of all these signs. Apart from this, in this particular explanation, you will see it in other geometric questions or theorems, topics, shapes, figures. So when you want to draw, you draw straight line and straight line. You don't need anybody. When some mathematician sees this, you don't need anybody to tell you that this angle is 90. How do you know? Because of this straight line and this straight V line. It tells you that this is angle 90. This angle is 90 degree. So let's come back to the theorem. Say angle on a semicircle is equal to 90 degree. So this is the angle on a semicircle. This angle is on this semicircle, so it must be equal to 90 degree. So let's say in a question, and I tell you, I draw this line, I say find S. Let me say this is S. You just say S is equal to 90 degree. You don't need anybody to tell you. What's the reason? Angle on a semicircle. So just write it like that. So that is how that's that particular word theorem. Okay. The next one, we take note. When you see, take note. Let me emphasize on this. When you see, if I draw a shape like this, for instance, and I draw a line like this, it does not mean this is a right angle triangle. For you to know that it's a right angle triangle, I must write this sign like this. For you to know that it is a right angle triangle. So for you to know that this one is a right angle, that's 90 degree, I must draw it like this. So if I draw it curved like this, it is not, or I leave it empty, it is not. You don't have any proof you can't use any other thing to know that yes, it is a right angle triangle. You must see that sign like that for you know that it's a right angle triangle. Even if I draw something like this, and I put this line here, you know that this angle is a right angle triangle. Why? Because of this sign here. So it's not really how it does not really based on how you draw it on the board, because you are not drawing it to scale here. It's based on this sign for you to know it's a right angle triangle, unless you calculations leads you to it. But if you just have a normal figure like this and you see this sign like this, you should know that it is a right angle triangle. So put that at the front of your mind as you are going to be saying something like that in examples. Now the next one we are going to be, which will be the last one for today, which is the exterior angle of a cyclic quadrilateral is equal to the interior opposite angle. The exterior angle of a cyclic quadrilateral is equal to the opposite interior angle. So let's say this is a cycle and you have something like this. In a cyclic quadrilateral, they must touch the edge. Let's say this is a cyclic quadrilateral now. If I extend this line out here, this is an exterior angle. So this exterior angle must be, whenever you have exterior angle like this, just know that this angle, when you have a shape like this, just know that this place, if this place is S, this place is the opposite interior angle. This place must also be S. So if I tell you that this place is 5, you should know that this place is 5 too. If I give you here and tell you this place is what? 40 degree. Okay, 40 degree. That's from, look at where I draw my this sign from. I drew it from here to here, not from here, from here. So if I tell you that this place is 40 degree, automatically you know that this place is 40 degree. That's what this part is saying. The exterior angle of a cyclic quadrilateral is equal to the interior opposite. This is the interior opposite angle. Is equal to the interior opposite angle Okay, so these are the theorems we are going to be treating today. In our next video, we'll talk about the remaining parts of the theory, which is the remaining numbers of theories, about, let me say, 6 more theorems. Then we'll move to maybe solving examples, maybe up to about, let me, 7, 8, 9, 10, at most 10 examples. Then we'll move to another key topics in mathematics. You know why I decided to take this particular topic and do it, try my best to do it well? It is because when you go to, for instance, to WAEC, go and check WAEC objective every year, go and check it. You will see bulk of questions under this topic. You will see it. You will also see this topic in NECO. You will see it in JAMB. Okay, so that is why I'm taking my time to treat this topic. Make sure you follow, you know, the importance of theorems and how to apply them. You know, in this topic, you have to practice. If you don't practice, you won't know. It is key for you to practice as a student. Even your teachers practice. I practice, so you must practice too. If you don't practice, don't expect yourself to become good at what you are doing. So thank you for listening. Thank you for your patience in this very class. And if you are in Edo State and you want a physical class, we are close to Belisima Junction. We are in Edo State, Saple Road at Bypass or Hawan. We are very much close to Belisima Junction. You can do yourself well to come and join us in our physical classes, as we will be glad to accept you into our physical classes, and we promise you to teach you well. Trust me, you're going to excel well in your various exams. Are you a nursing student? Are you a WAEC student? Are you a JAM student? Whatever, in as much you are preparing for any of these exams, just come to a Fruitful Ground tutorial. We are going to teach you and make sure we give you the best. Thank you. Bye. We'll meet in our next video. Bye.